Okay, in this video, we're going to find the atomic mass of an element from its natural isotope abundances. Remember that an isotope is an atom that has a different number of neutrons, and in nature, these atoms are in different proportions. For example, we talked about carbon 12, we talked about carbon 13 and carbon 14, and we said that the isotope carbon 12 is the most abundant in nature. It has an abundancy of about 98%. So when you look at carbon in the periodic table and you look at carbon's atomic mass, you're going to see that the atomic mass of carbon is 12 point something. And that the reason is because carbon 12 is the most abundant. So we're going to figure out how to find atomic mass. The problem says magnesium has 3 naturally occurring isotopes with masses of 23.99 atomic mass units, 24.99 atomic mass units, and 25.98 atomic mass units, and a natural abundance of 78.99%, 10%, and 11.01% respectively. Calculate the atomic mass of magnesium. Okay, to calculate the atomic mass, what you need to do is set up a proportion. I don't know if you remember from math, there's a formula called is over of is equal to percent over 100. You use this formula to find the percent, or you use it to find the total amount or the partial amount of whatever it is that you're given. So all we're going to do is plug the numbers into the formula, and we're going to find out the is, because in this case we're given the percentages and we're given the total amount of what the atom weighs. Okay, so let's do the first one. The first one weighs 23.99 atomic mass units, and it has a percentage of 78.99% over 100%. Okay, and you solve this by doing cross multiplication and then division. So you first multiply 78.99 times 23.99, and then you divide it by 100, and you get x. So let's find out what x is equal to. Okay, so I'm going to put in the calculator 78.99 times 23.99, and I'm going to divide that by 100, and I get 18.9497. 18.9497. Remember that in chemistry you always need to find the number of significant figures. So when we're performing the operation here, 78.99 has 4 significant figures, and 23.99 has 4 significant figures. Okay, so we need to use the numbers that are given. 23.99 is given and 78.99 is given. Do not use 100. Okay, you do not count the significant figures for 100. So this answer should have a total of 4 significant figures. So I'm going to draw a blue line right here, because this is where the 4th significant figure is supposed to stop. But don't round until the very end. Remember, in chemistry we do not round until we have everything. Okay, so let's do the next one. It's the same process. X over 24.99 is equal to the percentage, which in this case it's 10%, over 100. Okay, make sure that you write all the zeros. I didn't just write 10%, I wrote 10.00 because of the number of significant figures. 10.00 has 4 significant figures. Okay, so that's very important. Now let's see what this gives us. So 24.99, oops, let's go back. 24.99 times 10.00. I'm not going to write the 00 on the calculator, but I do write it on the paper so you can see it. Divided by 100, I get 2.49. So x here is equal to 2.499. Remember that we need to round to 4 significant figures, so I'm going to draw a line 1, 2, 3, 4th at the 4th number. Okay, and now we're going to do the last one. So the last one says x over the mass of the last one is 25.98. The percentage of abundancy is 11.01. Okay, and again, I'm going to go to the calculator and find out what this is. So we have 25.98 times 11.01 divided by 100, and I get 2.8603. X is equal to 2.8. Let me see, 2.863. Okay, and we need to round to, let's find out how many significant figures. This number has 4 significant figures, and this number also has 4 significant figures, so your answer has to be 1, 2, 3, 4 significant figures. Okay, so this is the first step. Okay, so that's the first step that you do. And after you solve all of these 3 numbers, what you're supposed to do next is you're supposed to add all of these numbers together. Okay, so add all of these numbers. And we're gonna have 18.949 plus 2.499 plus 2.8603, and you get 24.3081. So the total, the atomic mass is equal to 24.3083. 24.3083. Okay, so now is when we round, and based on these starting ones, we need to have 2 decimal places. Remember that when you add, you need to add based on the number of decimal places. This has 2 decimal places. This has 3 decimal places, and this has 3 decimal places. So you're supposed to pick the one that has the least decimal places. This is the one with the least decimal places. That's the addition rule for significant figures. So we're gonna round to 2 decimal places when we add. So this is the second decimal place. So the answer when you round, it's gonna be 24.31, and this is the atomic mass for magnesium. So magnesium has an atomic mass of 24.31. And if you look at the periodic table is going to tell you that magnesium has an atomic mass of 24.305, about there. But remember that since we're rounding, it becomes 24.31. And I'm going to do another video with another example of this.